No, I'm trying to display the class. Okay. Yeah, that's what I'm saying.
Okay, click. You click. You click back and work your slides. Yeah.
Okay.
Yeah.
All right. Hey, everyone. Welcome back. Hope you guys enjoyed your weekend. Today, we're going to be covering abstractions. So last class, we covered relational databases, and now we're going to delve deeper into that actual topic. So before we start, some announcements. We have PA3, which is due tonight. We're currently grading, or we just finished grading PA1, so that should be out later this week. But for PA3, remember to double check your roots, always test the Postman, and then follow the file submission format. So that's one thing that we found a lot in PA1, where try to follow the API specification like to a T. So including status codes, including the exact response format that we want, because that's exactly how we'll be testing you. And that's kind of how in the real world, that's how your front end would interact with your back end. So you want to make sure you adhere to those standards. And then one other thing is that I don't know if you guys have heard much about like the hack challenge for this class. So basically, at the end of the semester, you guys are going to be paired, you guys are form groups, and you're going to be paired with another team from iOS, a team from Android, maybe a team from like design, and you guys can build an app together and compete in a hackathon where you have a chance to win like prizes for like best backend, most creative, stuff like that. So you guys might have been added to an ed discussion for that, or you will be in the coming week. So just keep your eyes out for that. And yeah, does anyone have any questions before we begin? Sounds good. So before we start abstractions, we'll go into a little bit of review from last week. So again, just thinking of our server or client server model, we have our server, and that interacts with our database through SQL commands. So a server requesting data from the database, and then the database returns the actual data adhering to the SQL command. And the different types of data relationships we have in our database, there's one-to-one, one-to-many, many-to-many. And the ways we kind of make those are through foreign keys. Again, with a one-to-one, you have a foreign key referencing like one entity in another. So that could be a student to their net ID. One student has one net ID, one net ID has one student. And the way we do that is through a foreign key with a unique qualifier, which restricts the amount to one. One-to-many, again, you can have like one class to its, I don't know.
Student.
Yeah, student, what?
Student.
For one-to-many.
Oh, one to many.
Trying to think of an example of that right now.
People to post.
People to posts. So you have a user that can have many posts, but a post can only have one poster. So that's how you can do one-to-many, and that can be done through, again, a foreign key without that unique qualifier, so then you can map multiple. And then many-to-many, you can have students to classes. So one student can have many classes, one class can have many students, and you do that through a join table, which is a table consisting of two columns with foreign keys. So just going over that again, just to make sure this is really like hammered home. So we have our user table and our profile table. This is going to be a one-to-one. One user has one profile has one user. And we relate the ID of the user table to the user ID column in the profile table. So that way we know like the profile with ID 40 references my user. And then we can do the same thing for Tony. And then here's the one-to-many. So again, since we don't have the unique qualifier, we can have multiple referencing the Igor album. And then we can do the same thing for the other album. And then finally, this is the many-to-many relationship. So we have my net ID and the courses I'm taking. I can be enrolled in the course with ID 1110 and the course with ID in 1998, which refers to CS 1110 and CS 1998. You can do the same thing for Tony. Yeah, same thing for Tony. And then obviously the reason we do this instead of using like any other method, like lists of things or something like that, is because we can easily just insert someone into a new course if they decide to enroll, or drop a course, we can just delete the entry, and that saves a lot on space and time efficiency. So we went through a lot of the actual like data, like how we can represent data, but it's something we didn't really talk about is the like to interface with the database, we use SQL, right? To see the query language that we use. But there's a lot of like drawbacks that you guys have probably seen in your assignments. When working directly with SQL, it's often like prone to mistakes and stuff like that. So I remember one person, they forgot one comma and their entire assignment wasn't working, or they forgot to put a semicolon and the entire thing blew up. So some drawbacks of those are like lower code readability, susceptible to vulnerabilities, like I said, and runtime exceptions not handled well. So the runtime exception is especially true, which is the time when like you forget a comma and it says like, oh, this query is not valid, let me just crash the program or something like that. And then the susceptible to vulnerabilities part, we're going to be covering a little bit later in the lecture. That's actually, if you guys have ever heard of these massive like data leaks or something like data breaches through like Facebook, Meta, whatever, the reasons why those happen is like, and the ways that people actually do it, we'll like kind of delve into here. So you guys can see really like when you're working with the backend, there's a lot of things to keep in mind. And then finally, lower code readability. That's gonna kind of goes without saying, like it's kind of hard to read a really long SQL query like this, where basically it's just selecting like the name and language of a country, like grouping by, having a lot of conditions. And obviously, no one really knows what this actually saying. And then, so the specific vulnerability that we're going to be talking about is called SQL injection. Has anyone ever heard of SQL injection? One, two. Okay, so it's actually kind of non-existent anymore, but back when the web was like newer, this was a really big problem, and how to secure your database was a really big issue that a lot of developers were facing. And the key thing about SQL injection is you can kind of like, the way like a hacker would do it was creating like a specific query to put into your database that'll basically give you access to every column in there. And so we're going to be going into that in a little bit. But basically, it allows database access to like a hacker who can like query data they're not supposed to, so like bank records or like something like that. Or you could just straight up like delete an entire table. And so that company would have no more users or something like that. So we'll go into an example of actual like SQL injection. So just consider this basic like login page. So you have two inputs. You have an email, a password, and then you hit login, it sends it to the backend. So the way we kind of would check that on the backend is we have a stored email and a stored password for a user, and we check if those two inputs match pretty much. So the way we would kind of do that is, so select all from user. So that's basically selecting like every single like entity in our user database, every single user, then where the email equals, and then $email is going to be the input to the top input, and then password is the one to the bottom. So basically, if we have a user which matches email and password, then we know that this will return at least like one result, which means the user successfully logged into some account, right? And so a way just to like represent this, so let's say we have a user abc123@cornell.edu whose password is backend. So we just put those straight into the query, and if this returns a result, then we know there's a valid user. But if you were to do like an unsuccessful login attempt, so if I come back to this and I change the username, let's say the username stays the same, so abc123@cornell.edu, and password, let's say I say it's now front end. So then obviously this wouldn't match, this command wouldn't match, and no query would be returned. So it would be effectively the same thing as saying select all from user where false and false, because those two conditions are evaluated and they equal false. And basically what this will do is just return nothing. So how SQL interprets this is selecting every user where false, which just means don't select anything pretty much. And the opposite is true. If it's where true, then it would select every user. So if we do true and false, obviously that was the scenario before where ABC, we had the same username, but we changed the password to front end. So the first one matches up, but the second one doesn't. So true and false still returns false. But if we were to somehow change that so that we can make true and true, then we could return the actual every user in that database. And so that's kind of what the basis of SQL injection is. So if we go back to our example and just say $email is just like a variable representing like the email that we put in. $password is just a variable representing the password. And then we put in this special query here, which is XX quotation or 1 = 1, a semicolon dash dash. So that looks very cryptic, but basically what this is saying is at the bottom here. So select all from user where email equals email. So the variable representing it, that could be anything. And then the password equals XX quotation or 1 = 1. So the way we specially crafted this so that this XX could actually be anything. So you could have like a huge quotation or 1 = 1. Basically, since we're putting the values directly into the query and we're not like checking the input or anything, we just grab that and just insert it into this, like, and it turns out into this long query. And the way SQL kind of interprets this is select everything from user where email equals email, whatever, and password equals whatever, or 1 = 1. So obviously, you know, 1 does equal 1, that'll return true. So this is kind of like the end of our SQL statement. And then we put this dash dash in SQL. Dash dash means comma, comment, sorry. So what this will do is just comment out everything else in that line. So if we had another statement like select all from user where email equals email and password equals whatever, and like user ID equals whatever, that user ID part is just commented out. It's not even read by SQL. And that's kind of the way we manipulate a database into doing what we want. So if we were to actually evaluate this, it'd be false and false or true, which, as we know, would simplify to false or true, which simplifies to true. So now we have a way of accessing every single user in that table. Because if you do where true, it'll just return everything. So this is kind of where the ORM comes in. ORM is object relational mapping. And it kind of solves that problem of SQL injection and the vulnerabilities and the readability and stuff we mentioned before, where we now represent a table in our database as like an abstraction. So if you guys remember from like Java or Python, you guys have this concept of classes. So you can create a class, call it whatever you like, and a class can have certain like fields within it. So just certain variables that represent something. So we kind of create the same thing with this ORM, but instead of the fields, they're actually like columns in your database. So in this way, which we'll give you an example later on, but in this way, we can kind of query and manipulate the data using like the object representation in Python rather than actual SQL, while we can still preserve like the SQL and the storage benefits. So what we see is just Python code, but what is actually being executed is SQL code that's like written by like experts. There's no chance of SQL like injection or anything like that. And it gives us this ability to like reason about like entries as instances of an object. So creating a new object of that class would represent a new like row in that database kind of. So we can kind of compare the two. So on the left, we have this actual SQL. So we're creating a table with ID, integer primary key, name, text on null, age, and integer. That part should be pretty like familiar to you guys. This is just creating a basic user table. But the equivalent in our ORM or object relational mapping is this one with, we create a class called the user. And this is just Python syntax, by the way. Create a class called user. It has an ID field, which equals like a special type of like object in the ORM. And then we can specify the actual fields that it'll take. So this column is going to be representing only integers, and this is going to be the primary key column. And then we have a name, which is a string, and then an age column, which represents integer. So one common one that we're going to be using for this course, one common ORM for Python is called SQL Alchemy. And it comes built in with a lot of queries. So getting everything from a data set, like filtering by ID, stuff like that. You guys won't have to write that anymore. It just comes built in with SQL Alchemy, and it integrates pretty well with Flask. So some benefits, as before, like these more readable code because it's now Python instead of that huge like SQL query. It's now abstracted away from SQL, so you're not writing SQL anymore. You can just write pure Python. And then your database and application use the same logic, same language, same everything. So it allows like that seamless like compatibility with your application and other databases. And now it's actually secure from like SQL vulnerability. So instead of like substituting the values directly in, we can circumvent that and use this way of preventing SQL injection. And now for some drawbacks. Obviously, whenever you add another layer of abstraction, it's going to slow down whatever the thing is because you need to translate the Python code down into SQL and then run that SQL code rather than just running the SQL code directly. And then you also increase the amount of code in your application. So now it's SQL plus that abstraction. And then there's also a potential for misuse because, as always, when something becomes too abstracted, and there's not like a lot of documentation or something, the message or like the meaning gets lost. So now we're gonna go a little bit more into like the difference between App.py versus db.py like going forward. So starting from like this assignment and going on. So obviously your App.py is going to be pretty much serving the same task. So it connects a server to the client. It's basically where you define all your routes and responses, and it handles logic like input validation, like the errors and stuff like that. And then the db.py actually handles like the connection from the server to its database. And then now it'll define the tables and columns, not with SQL, but with SQL Alchemy with Python code through the ORM. And now it'll insert, update, retrieve, and delete. But these methods are actually now going to be like pretty much provided to you through the ORM. So there's going to be a lot like less work involved in the db.py. So just going over the client server model, just once again, just to drive it home. So starts off with your client. They send a request to the server. The server, they send a request. It triggers a route. Get some data associated with that route from the database. You get that with a SQL command, and then it returns back data. And then the backend again, the server returns that new response with the new data, and then it provides the response back to the client. And now, any questions before we go to the demo? Yep. So for Python, since it's interpreted, not really, but in the real world, one of the drawbacks of SQL Alchemy and other ORMs is that it does increase, like it slows the query time itself and the compile time. So, but it's not a very significant change. Like you won't notice in these assignments. A lot of big companies also use ORMs, even despite those, because they're kind of better just in the real world. But yeah, there will be theoretically, but it's not noticeable. Any other questions? All right, sounds good. We can get into the demo.
All right, so hello everyone. So for today's demo, we're kind of going to be building again like our task subtask model, but instead we're going to use ORMs instead of like the raw SQL queries that we've been using previously, like within the previous demo. So first thing we're going to want to do is go into whatever directory our source, I guess file is. So I'm going to go do that right now. That's in my documents, or I guess I'll just open a terminal right here. So now, okay, so I'm in my source folder. So if I just do code dot, then we're, I guess, in the demo file over here. Yeah, that's good. All right, so yeah, so this, I guess, app.py looks a little bit different from, I guess, what we've had in the past. There's some extra stuff at the top here that I'm going to explain in a little bit. But yeah, so all this stuff over here is basically related to our ORM. It's to set up the ORM that we're going to use, which is SQL Alchemy over here. And so with this ORM, now we're not going to be running like raw SQL code. We're going to be representing like our queries as like entities that it's kind of going to help you program in more of like an object-oriented way as opposed to like running those like raw SQL commands in the previous demos. So at the top over here, we have import JSON, and then we are importing our database file over here, and we're also importing Flask, which is the thing we're using to, I guess, run backend. So next thing is our DB file name. This is just the name of our, I guess, database app. Since we're doing this like to-do, I guess, app, we're just naming it to-do.db. And then app equals Flask name. This is just going to be the instantiation of Flask, which helps us like start our app. And then these next three things over here are a little bit, I guess, more complicated. So the first thing is this database URI thing over here. What this basically does is it specifies the SQL library that we're going to be using. There's a bunch of different variations of SQL. So we're going to have SQLite in here, since this is the version of SQL that we're using. And DB file name is saying that this file is going to be our database file. So this thing is going to be our database file. Then the next thing is this track modifications thing. So right here. And we're setting this to false to minimize resource usage. So SQL Alchemy has this event listener system that basically allows you to track your modifications that you make in your file in your database. You can set it to true and actually see like what you're changing in a database. But it's pretty resource intensive. And since this is a pretty small app and we kind of know what we're changing, we're just going to set this to false for now. And then the last thing is this echo thing right here. And what this basically does is like, so the ORM, like you said, is kind of a wrapper for like SQL, right? And so the ORM is kind of like actual raw Python code that kind of encapsulates our SQL code. So when we run our app, what this echo thing is going to do, it's going to translate our Python like code into these raw SQL queries in the terminal, so that when we run our app, we see what queries we're executing, and it's going to make it a lot easier for us to debug, in a sense, like if our queries are wrong. So this is why we have this thing set to true. And then the last thing over here, this stuff kind of initializes our app. db.init is pretty straightforward, it just initializes the app. And then over here, db.createAll. This is kind of analogous to that self.create task table and the create subtask table that we had in the previous demo. And so this just kind of does that all in one line of code. And then again, we have these success and failure responses. It just kind of generalizes the response format. So you don't have to type like json.dumps all the time. And then we have these default parameters, like I explained before. If you don't put in anything here, it's going to be 200. But if you specify that it's like 201 or something, then it's going to be 201. And so, yeah. So now we're going to go to db.py over here. And so we see that we have nothing here. And the reason that is because we're going to be creating like actual Python classes with actual like Python objects in these classes, as opposed to like executing like the raw SQL code like in this file. So the first thing we're going to do is create our task class, and this is going to represent like our task like object. So we're going to go over here and we're just going to say class task is a db.model. And so this over here tells SQL Alchemy that this task model is a model in our database. And a model is going to be like a blueprint of the objects that we're going to be making. So I guess with this blueprint, we're going to have like some attributes that go along with a task. So next thing, probably going to want to have some documentation. So it's a task model. So, and then, so we have a table name first that we have to create. And this is essentially, yeah, just our table name. And we're just going to be naming this tasks over here. So if you guys remember, the first thing that we had in our task model, it's some sort of primary identifier, which is going to be an ID. So instead of doing this like, SQL command where it's like self.con.execute, and then we have like select all from whatever, we're not going to be doing this instead. This time, we're going to be doing something that's a little bit easier to read and kind of is relatable more to like object-oriented programming. So we're just going to have a variable that's literally just ID. And this is going to be a db.column over here. And what this tells SQL Alchemy is that this ID field is a column. And the nice thing is that since it knows it's a column, it prepares the attributes for us. So what we can do is we have over here db.column, and we have db.integer, and that's basically saying that our column over here is an integer. Then we have this field called primary key, and this tells us that the ID is indeed the primary key. And then we also have this like parameter field called auto increment. And so this kind of tells SQL Alchemy to auto increment the ID field every time a new task is inserted into here. And so you can see from like how we're, I guess, coding this is it looks kind of neat. Like SQL Alchemy like has all these parameters in for us. Like we don't have to remember like a bunch of keywords or anything. And it's just a lot easier to just write out. So this is going to be your ID field. The next thing we had in our task model is like a description. So we're going to have description is again db.column. And so our description was some sort of text in SQL, right? So we're going to make it a string. And then we want to have some sort of description in our task. So we're just going to have this thing nullable over here. This is simply going to be false. And then another thing we have is done. And this is going to be db.column again. And so we have db.integer, we have db.string. What is, do any of y'all know like what, I guess, our first parameter over here is going to be? Like done is, does anyone remember? Yeah. Yeah, so we're just going to have db.boolean over here. And then again, we're going to want it to have something. So we do nullable equals false. So we had some subtask like field in the previous demo here. We're going to get back to that since we haven't actually implemented the subtask class yet. So yeah, so that, I guess, instantiates all of the, I guess, fields that we have for the task model right now. And so now we need to be able to initialize this new like task object, right? So we're going to do this with the init function. So we're going to do define init self, and then we're going to have this parameter called keyword arguments. And so what this basically does, it's just an abbreviation for, yeah, keyword arguments. And it allows you to enter any sort of parameters and it turns it into a dictionary. So I'm going to show you real quick what that kind of does. So in the terminal, I'm going to run Python 3. So we're in Python right now. So I'm going to define this function, I guess, foo over here. And this is going to take in parameters as keyword arguments. And so over here, we're just going to print these keyword arguments. And then let's do like foo. And then let's say our parameters are like name is Tony. And then let's say my status is, I don't know, hungry. Let's see. Oh, I didn't. Okay. Okay, yeah. So what this basically did is it took these, like it took a parameter and a value and it just maps it to a dictionary. So this is essentially what the init function is doing over here, which is really nice. So this is going to initialize the task object or entry. And so over here, we're going to have, so we have two things that I guess we want to initialize right now. So we have self.description is going to be keywords, keyword arguments, .get description. And remember, these keyword arguments are like a dictionary. So this .get thing just gets whatever entry is in the description field. And if this thing is none, let's say a user forgot to like put something, we can initialize the default parameter as the empty string over here. And then the next thing is self.done. And so we're going to do keywords.get done. And then let's say if no one put anything in here, if they're probably putting it in here, that means it probably has to be done. So let's put in as they haven't done this particular task yet. And so, yeah. So then the next thing we want to do is have a way to kind of express like this task function, like have someone see like what's actually in it. Because I mean, we have this right here, right? But we need to have some sort of way to like return like a task like object, right? So the next thing we're going to want to do is have some sort of serialize function. And this is going to serialize like all the data of in the task object and kind of return it to whoever you want, such as front end. So we're going to define a serialize function. That's going to take itself as a parameter. And yeah. And so now that we're representing like each entry in our database as a Python object, we're still going to need to be able to send a response to front end that's kind of like more digestible and processable for them. And so we have entries in our database, and we're going to need to pull them out from the Python object that we've created. We can't just send front end like this entire object over here because they might not kind of know what to do with it, or it might not be in a compatible format. So what we're going to do is we're just going to return all of this stuff here as like a dictionary. So we're going to do is simply return. And then, so the first thing we have is the ID of the task, which is self.id. We have the description, which is self.description. We have done, which is self.done. And for now, I think that looks good because we haven't implemented subtasks yet. So now this looks good for everything. We have this task model. We have all these fields over here. We initialize it over here, and we return it right here. So all this kind of looks good so far. So now let's create, I guess, the subtask model. So again, does anyone remember the relationship between tasks and subtasks? Yeah, exactly. Since one task can have many subtasks, but each subtask only references one task. So we're going to keep this in mind when implementing our subtask class. So we're going to go over here and say class subtask. Again, this is going to be a db.model. So kind of SQL Alchemy knows that this is a separate like entity within our database. So this is going to be our subtask model. And so again, we're going to have table name equals subtasks. And so the first thing we're going to have is like the ID of it. So this is simply going to be ID equals db.column. Again, it's pretty similar to what we had above. So db.integer, our primary key is true. And the auto increment field is also true. Then we have description equals db.column. This is, again, going to be a string, just like in the previous model. And we're going to want it nullable to be false, because we always want to have something to have a description. And then the second to last thing is this done field. And so we're going to do db.column. It's going to be db.boolean. And then, yeah, nullable is false. And then the last thing we're going to have over here is this task ID, and that's going to be the foreign key, right? So this is the thing, I guess, that's pretty cool about, I guess, SQL Alchemy. So we got db.column, and so we have, again, this is going to be an integer, right? Because this ID over here is an integer. And then so SQL Alchemy kind of knows what's like coming. So it has this thing called a foreign key. It has it already built in. So we simply say db.foreign key, and then we do tasks.id. So basically what this is saying is this is a foreign key. It references the ID field of the tasks table, which is named up here. And so this kind of like creates a relationship. So, and then, yeah, that's really all we need to do to just create the relationship, which is really cool. And then again, we want a subtask to always reference some type of task. So we're just going to say nullable is false. And then again, so we created our subtask model, and now we want to initialize it. So we're going to define the init function over here. Self, again, keyword arguments. So it's going to initialize the subtask object. So again, we have our self.description equals keywords.get description. And then we simply have the empty string if nothing is put in. Again, we have self.done is keywords.get done, and then false as the default parameter over here. And then self.task ID is again going to be keyword arguments.get the task ID. And so, yeah, so the note is that there's no default parameter over here for the task ID, because this means that a subtask doesn't have like a task ID, which is wrong. So if this is the case, we can raise an exception in app.py, because that's where all like the logic goes. So we're never going to have like the case where this field is going to be empty. So this is why we don't need like a default parameter here. So we just leave it like that. And so the last thing we're going to want to do is write the serialize function for this subtask model. So we're going to define serialize self, and it's just going to serialize subtask object. So again, we're just going to return this as a dictionary. And so we have the ID is simply self.id. We have our description, self.description. We have done, self.done. We have our task ID, which is self.task ID. So now, I guess looking forward, so in our app.py, we're probably going to have some like get all tasks route, right? And let's say we're going to want to, I guess, see all the subtasks associated with the task. So I guess what we're going to do up here is, let's say we want to see like all the subtasks of a task, right? So what we're going to do is we're going to have a subtasks field over here. And so the way we're going to do this is we're going to have some sort of list of subtasks for every task, right? And so so the syntax of this is going to be s.serialize for s in self.subtasks. And I forgot over here, up here, we also need kind of like a subtasks thing. Okay. I think I got too far ahead of myself. Scratch this for now. We'll go over this tomorrow. Kind of got ahead of myself. But yeah, I think this is it for today. So to recap again, we have our task model. We have all these fields over here. And this initializes it. Serialize function kind of returns it into a nice format for front end to use. And then we have the same subtask model over here. We have our task ID over here that kind of creates the relationship with this db.foreign key. This thing initializes the subtask, and then the serialize just returns the subtask as a dictionary. And so, yeah, that's going to be it for today. And yeah, let's get on to the Kahoot.